Solve polynomial functions by factoring. So now we're actually going to solve one. Instead of just factoring it, we're going to try to solve it. And they say refer to the beginning of the lesson, but really what they're talking about there, the volume of the cube is the side length cubed. If the small cube is half the length of the larger cube, yeah, you can see that it's x, and the length of the whole cube is 2x, so that's half of it. And the figure is 7,000 cubic centimeters. What should the dimensions be? What should be the dimensions of the cubes? So the idea here is it's the big cube minus the small cube, right? Equals, let me actually write it on the same line here, equals 7,000. Well, the big cube is 2x cubed. So 2x cubed minus the small cube, its side length is x cubed, equals 7,000. Well, let's simplify that. 2x cubed is 8x cubed. X cubed is just x cubed, equals 7,000. Well, 8x cubed minus an x cubed is just 7x cubed. Ooh, look at that. That's real nice. I can divide both sides by 7, and I have x cubed equals 1,000. Now, if I'm solving, I want this to equal 0, so I can factor it out and use the zero product property. So what I'm going to do next is I'm going to subtract 1,000 from both sides, and I get x cubed minus 1,000 equals 0. And if you think about 1,000, it just equals 10 cubed. So what we have right here, x cubed minus 10 cubed equals 0, we have a difference of 2 cubes. So let's run that pattern. X squared minus 10 squared times x squared plus 10 times x, minus 10 squared equals 0. So the way this works, well, I could factor it a little bit more, can't I? Let's factor it more, because here I have a difference of 2 squares. So let's take it x plus 10 times x minus 10 times x squared plus 10x minus 100. I'll just make it 100 right now. All of that equals 0. So there I was just practicing what I did before on those last two steps of looking for all the different patterns I could. Now I have three numbers and all of their product is 0. So that tells me x plus 10 equals 0, x minus 10 equals 0, and x squared plus 10x minus 100 equals 0. Well, here x plus 10 equals 0, that's going to give me x equals negative 10. That doesn't make any sense for a side length, so we're going to not do that. No sense for side length. So I'm going to kind of ignore that answer there. But here I have x equals 10. That's a potential for a side length. Okay? But now there should be two more, and they come from this equation here. Now I said this is not factorable before, so that tells me I should just use the quadratic formula on it. And I know it's not factorable because that part came from the difference of two cubes pattern, so the quadratic that's left over is never factorable. Oh wait, I made that a minus there. That should be a plus. I'm sorry. Alright, so that I'm just going to use quadratic formula. Negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 100 all over 2 times 1. So, plugging that in my calculator, because I don't want to do that all by hand, let's take a look at the discriminant here. 100 minus 400, ooh, that's negative 300. And we've got x equals negative 10 plus or minus the square root of negative 300 over 2. 300, that's divisible by 10, or by 100, so I can take the square root of that. So that tells me negative 10 plus or minus 10I roots of 3 over 2. Can reduce that all down, and I get x equals negative 5 plus or minus 5I roots of 3 all over 2. Now, does this make sense for the solutions either? No, this doesn't make sense either. No sense to have imaginary length. So I don't really want to use that as my answer either. So the only one that actually works is 10. So there's my only answer that actually makes sense for the problem that I'm given.